In question 2, we're shown the trajectory of a golf ball. In part A, we're asked to show that the speed of the ball at its highest point is between 8 and 9 meters per second. Well, at its highest point, its vertical velocity will be 0, so all we need to consider is the horizontal velocity, VH. And this is 17 times cosine of 60 degrees. And this comes out at 8.5 meters per second. In B, part 1, we're told at 1.5 seconds the ball reaches its highest point, and we're asked to calculate the maximum height of the ball. Well, for this we can use S is equal to UT plus a half AT squared, which is 17 sine 60 times 1.5 for the time, plus a half times minus 9.81 times 1.5 squared. And this comes out at 11 meters. In part 2, we're asked for the distance between points F and G, the start and finish. Well, the time up will equal the time down, therefore the time of flight is 3 seconds. We know that distance is speed times time, and this is 17 cos 60 times 3 seconds, and that comes out at 25.5 or 26 meters. In C, the ball is now hit at the same speed but at 30 degrees to the horizontal, whereas to show that it would still land at point G, well, we can again use S is equal to UT plus a half AT squared, but now we're looking in the vertical direction, so I'll have up as positive, and when S equals 0, when the ball is at the ground, we have 0 is equal to 17 sine 30, the initial vertical velocity, times t, plus a half times minus 9.81, because the acceleration is down and I'm taking up as positive, times t squared. So 0 is equal to t, 17 sine 30 minus a half times 9.81 times t. So this gives us t is equal to 0 seconds, the start, or t is equal to 17 sine 30 over a half times 9.81, which is 1.73 seconds. We can then use the constant horizontal velocity to do S is equal to Vt, which is 17 cos 30 for the horizontal velocity, times the time of 1.73 seconds, and this gives 25.5 or 26 meters. In D, we're asked to consider which of the two trajectories would we choose to travel a longer distance after hitting the green at G. Well, the second case has a greater horizontal component of velocity on landing, so would roll further. They have the same speed, but at different angles, so have different velocities.